Practice exam number 5, question 1. How do we do it? That is weird looking. What do we do when they've got like 4th power and 2/3, 1/3? That's craziness. Remember those kind? You let W be the middle. Those are it's been a long time, I know. Let me write that out for you. So you got to have on your 3x5 card for the test after tomorrow, you got to have some plans. Here's one of them. When 4th power or 2/3 power or repeated parenthesis, any of those kind, let W be the middle, W squared the front. Solve for W, and then go back to the original letter. And solve. So that's the plan. That's how you handle these. Let me show you what I mean in particular. So, what is it? 15x to the 4th. So number 1 minus 13x squared plus 2. So has everybody got that copy down good enough? Maybe I'll write some of that on the board. Let's just crank this one. So in the front, W in the middle, remember? So when you see x to the 4th or x to the 2/3 or a repeated parenthesis, I'll show you all 3 of those. You put W in the middle, W squared in the front. Remember, it's like an actor playing the role, right? W is pretending to be x squared. See how W is an actor taking the place of x squared? And if W is x squared, then x to the 4th being twice as big must be W squared. Does that make sense? That seem reasonable, right? W always is an actor. He always goes in the middle and takes the place of the x squared in the middle. And therefore, W squared must go in the front. All right, now solve for W. How do you do that? I'd go to the quad. I'd probably just dive right into the quad to solve for the W. Remember the quad? Your favorite formula. Negative b plus or minus square root b squared minus 4ac all over 2f. Plug into the quad. Use your calculator. How are we doing? You getting this to work out? So, everybody to hear? This coming out okay in your calculator? Now, what do you do at this point? What do you do with a plus or minus? You do the two different options, right? Remember that? So it's going to be 13 plus 7 over 30. 13 minus 7 over 30, which is 20 30ths, which reduces to be 2/3. And this is 6 30ths, which reduces to be 1/5. Now, are we done with the whole problem? No, those are the W answers. You see, that all came from this equation here, didn't it? The W equation. So we still have to go back and finish for X. That's what I wrote up there for you, right? Is you first solve for W, then you got to go back to X. So those are the W answers we just got. So that means W is 2/3, or W is 1/5, right? Come up here. Now, how do you go back to X? What is W? Remember, W was an actor. He's in the middle. He was playing the role, standing in the place of X squared. This means X squared is 2/3, or X squared is 1/5, right? Because W is X squared. W was the actor standing in the middle, where X squared was. So now we got to finish X. How do you finish solving that for X? Square root. When you put a roof on the house, up and down the ladder. X is plus or minus. Now, when you have a square root on a fraction, you put the square root on the top and the bottom, right? Square root of 2 over square root of 3, and square root of 1 over square root of 5. Now, we cannot leave roots in the bottom. Right? Am I racing ahead of you? You good? You caught up? So then last step, multiply top and bottom by root 3 on that one, root 5 on the other one. So X is plus or minus root 6 over 3, plus or minus root 5 over regular 5. And there we go. We got our 4 answers. Questions? Can you do that, you feel like? Be able to do that on the exam day after tomorrow? Can we go to number 2? So what's the game plan then? You got X to the 4th, or 2/3, or repeated parentheses. You let W be in the middle, W squared in the front. Solve W. Here we had our answers for W. And then you go back to X right here and finish solving for X. So you're using W as an actor to make the problem easier in the middle. And at the end, then you go back to X. All right, let's try number 2 here. 2/3 minus 3x to the 1/3. Minus 18 equals 0. All right, try that one. Same kind of thing, right? 4th power, 2/3 power. You're going to use W as an actor in the middle. So let W be in the middle. W squared in the front. And then solve for W. When you're done with that, go back to X. So what do we always do on these kind? The front becomes W squared. The middle becomes W. All the numbers stay there, though. The 3 stays there. The 18 stays there. It's just the front becomes W squared and the middle becomes W. That's what I'm saying on the steps. Whenever you've got x to the 4th or x to the 2/3 or repeated parenthesis, W's in the middle, W squared in the front. All the other numbers stay put. Now solve the W. So let's solve for how do you solve? Well, you could just factor. You could do the quadratic formula if you want to. But this one's pretty easy to factor. What two numbers multiplied? What times what is 18 and adds to be minus 3? So what times what's 18?
6.
Yeah, 6 times 3 makes 18. Now remember the sign? Sign in the middle goes on the bigger. Minus 6 plus 3, huh? Minus 6 times plus 3 is minus 18. If you add them, minus 6 add 3 is negative 3. We good there? They multiply to be minus 18. They add to be minus 3. That's our numbers. And so remember then it's just opposite. Well, you can set each one to 0. And then you just jump it over. It's opposite. So we get W is plus 6 or minus 3. Now, that's all W stuff. W's over. We're done with W. Final step. Go back to X and solve. And where do we find the X? Maybe I should add to that. You go back to now go back to X in the middle. Why the middle? Because that's where W came in. It's going to be X to the 1/3. You see, W is an actor that was playing the role of the middle. And the middle was X to the 1/3. So whenever I say go back to X, I mean whatever X kind of thing was in the middle. Because that's where that's who W took the place of. So, all right, so W equals 6. Really, W was an actor standing in for X to the 1/3 all along. So we good to there? So X to the 1/3 power equals 6, or X to the 1/3 power equals negative 3. So X to the 1/3 power is 6, or X to the 1/3 power is negative 3. So what do we do with that? Well, what's our goal? We want to solve for X, huh? We want to just make that normal plain X. We don't want some weird 1/3 power on it. So how do we get rid of that 1/3 power? Opposite of a 1/3? 3. Right? You just go parenthesis 3 power, parenthesis 3 power. Right? Because what's 1/3 times 3? These just cancel, don't they? That just makes X to the 1, which is just normal X, isn't it? What's the other side? Well, whatever your calculator says it is. It's 6 times 6 times 6. 216, isn't it? All right, and then over here, same kind of thing. I want regular X, which means X to the 1. How do I get X to the 1? 3rd power, right? Cancels. X to the 1 over here, it's negative 3 times negative 3 times negative 3, negative 27. There we go. All right, you'll be able to do this? You can if you practice this over and over again. If you're having trouble right now, just practice it again, right? Try it again later. I was at some meetings with colleagues recently, and we were sharing different teaching ideas, and one of them said he uses the blank paper idea. I thought it was a good idea. He said he tells his students, just take out a blank piece of paper, write this problem at the top, and try the problem without looking at any notes at all. If you need to look at notes, if you get stuck and need to look at notes, do that. That's fine. But then try the blank paper again until you can do it without notes, or whatever notes you're going to use in your 3x5 card, huh? Yep, so make sure you can really do this, and you can, if you do the thing enough times, enough practice, you can do this thing, even though it's a hard one. All right, let's try, okay. So try that one. This is what I mean by, so when I wrote the steps out for it, and I said x to the fourth, x to the third, or repeated parenthesis. Right back here in the steps, repeated parenthesis. Then you do the same thing, w in the middle, w squared in the front, blah, blah, blah. See how we have the same repeated parenthesis? That's your signal. So you want to make notes. You got to make notes for yourself. It's that challenging. It's what separates the people that will put in that kind of work from those who will not. It's doing all these kind of things. Writing down on your 3x5 card. If I see the repeated parenthesis, I got to remember this process. Many people will balk at this. Well, they'll do it and they'll just go, shoot, I don't want to do all that. And they'll stumble into the exam and they won't get it right. It's all about time and effort. So you can do it. You can definitely master this stuff. It just takes some time. So that's one of this type. So put w squared in the front, w in the middle. Making sense? Just like the last two. W in the middle, w squared in the front. That whole parenthesis, repeated parenthesis thing. All right, take it from there. Factor away. Now we can factor that thing, right? 2 parentheses. What two numbers multiply to be 65? You can use your calculator. It's not something I usually know off the top of my head either. Just take your calculator and just divide by it. If you divide by 5, isn't it 5 times 13? So 5 and 13. So just when you got a weird-looking number like 65 at the end, just try dividing by different things. 5 and 13. How do the signs go? Sign in the middle? On the bigger? Like that? We good there? And so then we get W is minus 5, or W is 13. Like that. And so we're done with the W work. Okay, so we're done with the W work. Now, how do we go back to Y? It's the middle. Remember, it's always the middle. It's what's in the middle of this thing. So this becomes y squared minus 1 over y is negative 5. Y squared minus 1 over y is 13. We good? In fact, let me change the colors to make it easier to follow. Okay, so now, what do I do to solve those things? How do you solve the one on the left? Cross multiply, huh? Put this over 1, diagonal, diagonal. So 1 times y squared minus 1 is minus 5 times y. So y squared minus 1 is minus 5y. Jump over the minus 5y. Y squared plus 5y minus 1 equals 0. Now, how do we finish solving for y there? Quad. We're going to have to quad that side. Let's do the other side first off. How about?
Yeah.
Why don't we do that? I don't know if that's really much better. Let's see. Y times y squared minus 1 is 13y. Y squared minus 1 is 13y. Oh no. We're going to have to quad that side too.
Yeah.
It's double quad. I'm going to move on. That's what you can do the quad, right? Final answers are there. I'm not going to get through everything if I do the quad on both of those. You just got to do the quad on both of them and get your 2 answers from the left side, 2 answers from the right side. Those are your 4 answers. It's a long problem. All right, are we good with that? You okay with those kind? Those are difficult. X to the 4th, X to the 2/3 are repeated parentheses. W in the middle, W squared in the front. Solve W, go back to your original X, finish it up. All right, they're there for you. There'll probably be 2 of those on the real exam on Wednesday. All right, number 4, let me rewrite it for us. 6x, x plus 11, x minus 11 less than 0. All right. What are we going to do? This is a certain form you need to recognize. So you'll have to recognize this on the exam day after tomorrow. There's something in this problem that needs to jump out at you. It's not big, it's a little thing, but it carries a huge meaning. It needs to leap off the page and get your attention and say, because of me, you got to do a certain thing. What is it? The less than. That little less than. Remember, less than, greater than. We had a whole game plan for less than, greater than, less than equal to, greater than equal to. Step 1, change to equals and solve. Step 2, denominator alone equals 0, solve. Step 3, answers on the number line, check x equals 0 or x equals 1, true, false, true, or false, true, false. Remember that whole process? So you got to have that in your 3x5 card. You can do it. Many won't because it's too much work for them. So this is what it takes. Will you do it? So put this stuff on your 3x5 card and practice these problems. So, all right. So change. So first step, let's change to equals. So step 1. Change to equals. Solve. So I'll make this 6x times x plus 11 times x minus 11 equals 0. And I'm going to solve. How do you solve that?
6x equals 0. X plus 11.
Yeah, if you got a bunch of things, the first one is 0, the second one is 0, the third one is 0. So to get x alone in all those, divide by 6, jump the 11 over, jump the 11 over, negative 11 over becomes positive 11. So we got 3 answers, 0, negative 11, positive 11. Good? So far so good? Now that's all just step 1. We're not done there. That's all just step 1. Now we need to, step 2 talks about a denominator. We don't have a denominator. Skip it. Move right on to step 3. Put the answers on the number line. Remember that whole thing? We go to the number line now. So here's step 3. We go to a number line. Put the answer. One of them is like here at -11. And then there's one of them at 0. And then there's one of them at +11. And so, here, let me give a little more room there. +11. So now we've got sections on the number line, don't we? And so our answers are going to go either true, false, or false, true, false, true. It's going to switch back and forth, isn't it? So we've got to figure out which one. How do we do it? We check either x equals 0 or x equals 1. The easiest number, we try for the easiest number in all the world is 0, right? So we try for x equals 0, but x equals 0 is right there. I can't check that. That's where one of the breaks is. Does that make sense? I can't check a break. I've got to check between them. So I can't check x equals 0. So that's why I gave you 2 options. Instead, just go ahead and check x equals 0. You can check any number you want to, really. Remember, you're like an electrician checking for power. We're just taking our little multimeter and we'll stick in it in various sections saying, is there power here? Is this line hot? Is there power in this spot? My son and I ordered a new battery to do something this big, kind of a big, thick battery. I have a tennis ball machine, actually, that shoots tennis balls. I've had it for 10 years, and the battery went bad. I have 5 kids, so I line them up, and I do tennis drill. And I shoot that thing, and I with your ground straight. Anyway, so I ordered this new battery, and my 15-year-old was helping me get it installed, and so we're trying to put this battery into this metal case. And the top of the battery is a big, thick, tall, pretty powerful battery. And it's got these metal probes at the top. And I just didn't think. And so I'm putting it in a metal case. It goes in a metal case. And I shoved it, and it was fitting tight. So I pulled it real tight, and the metal case right across the top touched both the metal probes on the top of the battery. What happens when you take a positive and negative battery charge and you connect them with a piece of metal? The current runs between them, right? It's like taking the old stories where somebody would take like a wrench and drop it across your car battery. Don't do that, right? If you take a wrench and you touch the positive and negative cables on your battery, don't touch that wrench. There's current running across that wrench. That's what I did. We're in the kitchen. We're in the middle of the kitchen. And it's kind of stuck. I got it, Judd. I got it. I pulled it, and it slid in there, and all these sparks everywhere. Why am I telling that story? Oh, I should have checked for power. That's right. Anyway, so we're checking for power. John and I were like, we should have known that. Of course, that's metal. That case is metal. So we're checking for power. We're an electrician saying, which line is hot? Which line's got power in it? So check the easiest number you can, 0, but we can't do 0 because 0 it hits one of the spots. So do 1. Do x equals 1. So I'm going to say, all right, let's check x equals 1, which is right here. So I'm going to check x. Now, whenever we check anything in math, where do we check? The first one. Always the first one. So 6x, x plus 11. Here, I'm going to need to get a little more room here. X plus 11, x minus 11, less than 0. So let's try it. So plug in 0, 1, thanks. Plug in 1, plug in 1, plug in 1. 6 times 1, you get 12, you get negative 10, huh? So what's that? 6 times 12 times negative 10? I don't know what that is. It's something negative, though, right? Look, it's a negative number. Whatever it is, it's negative. 720 or something. Negative 720. Is that less than 0? Are negative numbers less than 0?
Yes.
Is that true or is that false?
True.
That's true. That line's hot. Better not touch that line. That line's true. That section's true. There's power running through that section, right? It's true. And then now we can just switch. The one right next to it must be false. This must be false, and the one in the front must be true. Must be true, false. Right? Y'all with me? These are dividers that divide one section from the next section. We good? True, false, true, false. Okay. So what is our answer? Well, it's the two true sections. It's this section, and we're always looking for the truth in math, right? Those two sections. So all the numbers less than negative 11 and between 0 and 11. How do you say that? X is less than negative 11. How do you say, right, because the X is the shading. So the X, the shading, is left of less than negative 11. And how do you say the other section? It's between 0 and positive 11. So 0 and positive 11, X is between 0 and positive 11. There's our answer. Questions on it? So you're going to have that on your 3x5 card for the exam day after tomorrow, greater than, less than those steps. These are some of the hardest things. We're starting out with some of the hardest things. These, those big power ones with the repeated parentheses, and now these ones, these are some of the hardest things on the test. We good? Questions I can answer? Okay. So what on this page, what on the test, what's going to jump out at you on this one? That greater than symbol, huh? That's what needs to jump out. Go through the steps. Step 1. Change to equals. So change to equals and solve. Now, how do you solve that? Cross multiply, good. Yeah, because whenever we have a fraction on one side, a whole number on the other, we always cross multiply, huh? Put that over 1, diagonal, diagonal. Boom, boom. Boom, boom. Like that. How do we solve for x? So to get x alone, got x's on both sides, right? Remember how that works? Get rid of one of them. Last step, divide by 2. 41 halves. You can make that a decimal, it'd be easier for you. 20.5. Just divide it on your calculator. So that's all step 1. It's all step 1. So what do? We just change to equals. So when you got a greater than, less than question, step 1 is change to equals and solve. Now, what is step 2? Yeah. Go back here. Did I write it anywhere?
Yeah, you did. Denominator alone equals 0.
There it is. Denominator alone equals 0. Denominator alone, nothing else. So step 2, I'll come over here. Step 2, denominator alone equals 0. So I grab the denominator alone, nothing else, equals 0. So that means x is 20. So we have a 20 and a 20.5 as our two answers that are going to go on the number line. You good with those two steps? So step 1, I change to equals and solve. Got x alone. Step 2, denominator alone equals 0. Okay. Now we go to the number line. That's step 3. So when I go to the number line, I'm only going to put two numbers on the number line. One of them is a 20, the other is a 20.5, huh? Let me scoot those over, really. It's going to be 20 and 20.5. So 20 and 20.5. So 20, or let me put it up here a little bit. So 20, hey Wendy, 20.5. So 20 and 20.5 are on the number line. So we're going to check for power, right? Like I should have with the battery. So it's either going to be true, true, or false, true, false. One or the other, isn't it? So you can check anywhere you want, any number you want. What's the easiest number in all the world? 0. So if we can do 0, we will. 0 is available, huh? 0. The line doesn't go through 0. So where's 0? In the left section, middle, or right? Left's over here somewhere, isn't it? I'm going to check x equals 0. Where do we always check in math? Step number 1. So I'm going to take x minus 19 over x minus 20 greater than 0. And I'm going to put in a 0, put in a 0. So minus 19 over minus 20 is greater than 3. Two negatives makes positive. Just divide that into calculator. Don't you get like 0.95? Positive, huh? Positive 0.95 is greater than 3. Is that true? That's false. 95 cents is not more than $3. Right? That's false. So that means that this is a false section, true in the middle, false to the right. Because it always switches back and forth, doesn't it? False, true, false. We good? Our answer is always, bless you, the true sections. So right there in the middle. So our answer then, the x is right in the truth. The x is right in the middle between 20 and 20.5. So between 20 and 20.5. There it is. There's our answer. X in the middle between 20 and 20.5. Remember, you put both the symbols are less than when you do the middle thing. They both go less than. Because it's like smallest to medium to largest. Small, medium, large. The small is smaller than the medium is smaller than the large. Small, medium, large. And there we go. Good. Questions there? All is well? I'm going to move on if you're good. So those were two hard topics, weren't they? We just spent a long time on those. It was a valuable time, though. The weird power things with the W's in the middle, and then the greater than, less than. So those are hard. You get it on those 5 problems. We spent like an hour on those. Almost an hour on those 5 problems. Those are long. All right. So we actually 53 minutes on those 5 problems. So how about this one? Remember the graphing stuff? What do we always do for the graphing stuff? Those are pretty quick. You'll like the graphing ones, right? What do we always do in the graphing ones? Remember we make a little table? A little XY table? And when we make the XY table, it's going to be easiest to plug in for whatever letter is on the right side. In this case, it's Y. See how they got it switched around? Normally we have Y on the left, don't we? See how they have Y on the right? So when they have Y on the right, you start with whatever letters on the right side. So I'm going to put in 0 and 1, two easiest numbers in all the world. All right, let's just keep this as easy as we can. Plug in the easiest numbers in all the world, 0 and 1 for y. All right, and so now what is x? 1/6 to the 0 and 1/6 to the 1. Right, isn't that what x equals? And what is 1/6 to the 0 power?
1.
Yeah, anything to the 0 power is 1, remember? Anything to the 0 power is 1. All right, and what's 1/6 to the 1?
1/6.
It's just 1/6, right? So let's put those on the graph. Here we go. Over 1, up 0, and over 1/6, up 1. There they are. There's those two dots. Which one of those graphs looks like it has those two dots? There's only one graph that has the over 1/6 up 1. Well, wait a minute, is that true? Maybe, actually, A and B look close, don't they? So, looks like it's going down to the right. A and B both look close. Oh! Yeah, it's got a cross. Thanks, Wendy. It's got to be A because see how it's going to cross down below, whereas B never crosses the line. It gets real close to the line, but ours is going to cross the line. So it's A. The answer is A. See that? Because ours is actually hitting the line right here. Then it's going to go down below it, isn't it? Whereas if you blow up B, it's actually a little bit above the line all the time. All those are just above the line. So it's not B, it's A. Is that okay? Feel like you can do that on the exam? So they're trying to trick you by putting Y over there on the right side. That just means you start with Y in the table. 0 and 1, two easiest numbers. That's how we do all the graphing. Plug it in 0 and 1 for whatever letters on the right side. All right, onward and upward. All right, we'll try it. What do we have to do? Find the inverse. Find the inverse. Yeah, skip that. Don't worry about that. I'm not going to ask you anything about 1 to 1. They're all 1 to 1. That's really a concept of pre-calculus. Don't even worry about it. Just do the find the inverse. Don't worry about the 1 to 1 question. Does it actually make you answer? It just says if it's 1 to 1, doesn't it? Say
If it is.
Yeah, if they all are. Determine if it is. If it is, yeah. There, don't worry about 1 to 1. I didn't even talk about that in class. That's a higher con. There, I'm just giving you 1 to 1 function. So just find the inverse. Remember, we had 2 steps for finding inverses. Remember what those are? Step 1, invert or switch x and y. Step 2, solve for y. So an inverse function is an inverting of x and y. Solve for y. So invert x and y, solve for y. So this is y out here. Switch x and y, solve for y. So step 1, this becomes x. And those guys both become y, right? Comes x on the outside, both those guys become y. Switched x and y. Now solve for y. How do we solve that for y? Nancy knows. She loves to say this. Cross multiply. That's right. To cross multiply, put this over 1, diagonal, diagonal, right? When you got a fraction on one side, whole number on the other, away we go. Like that. Distribute. Give you just a second on this one. I want to see if you remember. So distribute 9xy plus 5x, boom, boom. 2y plus 8. So what are we supposed to do? We're trying to solve for y, aren't we? Notice this term has a y and that term has a y. Remember we learned when y is in two places, what are you supposed to do? Get the y's on the same side. Step 2. Factor out y and divide. Remember that? Got to get the two y terms on the same side. So jump the 2y here, the 5x back. So we get 9xy minus 2y is negative 5x plus 8. Is that good? They switch positions. Signs in front change, don't they? When things jump to the other side of the equal sign. Factor out the y. Like that. And last step, divide by the 9x minus 2. There it is. Here's the inverse function. Or, now remember, I want to remind you, I don't want you to be fooled on the test. I really don't. I'm not trying to fool you, not wanting to fool you. But the multiple choice publisher's answers might fool you because they might have different signs. This is the same answer. It could be written in a different form. So don't be fooled on Wednesday. Because remember, they could change all the signs. Top and bottom. Because they just multiplied by negative. Well, they just happened to solve it a different way and came out looking different. So this would be the same as this answer. Wouldn't it? Do you know those are the same? Either one of those, grab them. They're the same. See how the blue answer, all the signs are switched. Negative 5x becomes positive. Positive 8 becomes negative. Positive 9x becomes negative. Negative 2 becomes positive. Right? All they did then, all you could do is multiply top and bottom by minus 1, which doesn't change anything if you do top and bottom by minus 1. That's the same answer. Or they could switch the order on the bottom and make that 2 minus 9x. That's the same thing. Remember, all that matters is signs in front. Order doesn't matter. Signs in front matter. So if you have a plus in front of that 2, that's the same thing as nothing in front of that 2. Minus in front of that 9x, same thing. We good? All is well. All right. Inverse functions. So 8's the same thing. 8 was another one of those. Find the inverse. Let's try number 9. So remember what that little circle thing means. What does that mean? Let's start with f of g, right? Let's just do this one. What does that mean, f circle g like that? Yeah, this means G is inside of F. Remember that? Putting your toaster in your refrigerator kind of thing? Right? We good there? So it means G into F. Remember, functions are always right to left. So that means all of G goes into the X slot of F. So this equals 3, 5x minus 4 squared plus 6. See how I just put all of G into the X slot of F? Am I good? Okay. And now where do we go from here? Well, I'm going to leave the 3. Going to FOIL this out. 25x squared minus 20x minus 20x plus 16 plus 6. 25x squared minus 40x plus 16. Distribute the 3. 75x squared minus 120x plus 48 plus 16. Last step. 75x squared minus 120x plus, is it 64? Here it is. How are we doing? So that was f of g. Remember that? Plug one function in the other. Now the other way, so that was fg. Here it says do g of f. I can do that down here real quick. That, remember, it's always right into left. So g of f means f into g. So that means go the other way now. Take all of f and put it into the x slot of g. You're always plugging into the x slot, right? That's the holes in the toaster, Sam.
How'd you get the extra 16?
Oh, it's 6, not 16, huh? Thank you. It should be 6. Thank you. I messed that up. What's that? 54? I made that 6 into 16. Thank you. So now g of f, so the thing you got to remember if you're going to do well on this question in 2 days is it's right to left, so f into g. So f into g. So take all of f, put it into g. So this will be all of f into g. So that'll be 5, 3x squared plus 6 minus 4. All right, and then we distribute. 15x squared plus 30 minus 4, whatever that is. 15x squared minus 26. There we go. Does it make sense? The little circle thing means plug the right function into the left. Functions always go right into left. I'm going to move on. If you're good, let's try 10. Can you do number 10? Logs. Those are more recent for us. Been doing some logs. A little over 24 minutes. We gotta get through the rest of these questions. Try number 10. Question.
Does that say negative 26?
I messed up. I'm just going quick here at the end. Yeah, plus 26. Thank you. All right, I'm going to go on to number 10. So what do? You got a log base 2. Now remember that 2 is lowered down on purpose, right? That's not a mistake or weird, right? That's very intentional, very meaningful. You need to know about that too. That 2 is lowered down, just like these are baseboards lowered down. It means their base, their bottom. Okay, so what? So what are we supposed to do? We got to get rid of that log word. Remember, we basically do logs by getting the log word out of there. How do we get that log word out of there?
2 base both sides.
Yeah, you 2 base both sides. Put a 2 low down. Notice I'm not writing that 2 up here next to it. The whole point is the 2's got to be low down, the 2's got to be low down. And then it'll cancel out the other one. Remember, logs are the opposites of powers, aren't they? That's what logarithms are. They're the opposites of powers. They're inverse power functions. It's like a poison and an antidote. What happens if you're bit by a poisonous snake? You need an antidote. That's how logs and powers work. It's the antidote. So x equals 2 to the minus 4. Now, what do you do with a negative power? What's a negative power do? That's one of the other things that's really important. Power rule negative. What do you do with a negative power? Yeah, negative powers are unhappy. Remember, they're negative where they're at. They're unhappy. They want to jump to the other side, and then they become positive. Becomes 1 over 2 to the positive 4, huh? And then you can just work that out. What is 2? Just use your calculator. That's 16, isn't it? 2 times 2 times 2 times 2. It's 1/16 is the final answer. So negative powers are unhappy. If they start in the top of the fraction, they jump to the bottom. If they start at the bottom, they jump to the top. They're unhappy where they're at in the fraction. And they want to jump to the other side. And after they jump, then they're happy. Then they're positive. So that negative power jumps to the bottom and becomes positive. All right, try number 11. Same kind of thing. Got to get rid of that log. Need the antidote. Probably going to need your calculator. Uh-huh. Okay, so how do we get rid of that log? What do we always do? 125 base it, right? On both sides. So x is 125 to the 1/3. Now, I would just use my calculator on that. Do y'all know how to do it? It should come out 5. Just take your calculator, take 125 to the power, and you probably, depending on how you calculator, they're all a little different. You might need to parenthesize that 1/3. Depends on your calculator. I'll write out one version. Be to the power, up arrow, or x to the y, depends on your calculator. Parenthesis 1 divided by 3. Parenthesis equals. It might be like that. Depends on your calculator. The answer should be 5. The answer is 5. So make sure you can get 5. Wendy is here. She'll bounce around and help you if you're having trouble on your calculator to get that answer. I got to move on so I can get through these problems. Try number 12. 12. What we learned to do is if there's just number here and a number there, no x's, we learned we can just do those in 2 logs. You just do the bottom one is the base, even though, yeah, he's the base, and the 1 over 625 is the top. The bottom go bottom, and the top go top. Hit the buttons on your calculator. Is it -4? The answer should come out -4. You able to get that? If you have any trouble, grab Wendy or myself. We'd be glad to help you. Try number 13. They want you to take, well, here, let me actually go to a fresh screen on that one. Try number 13. They want you to write it as lots of logs. And it'll be easier on the test because you'll see the 4 answers, the multiple choice answers, you know, and what you'll see in the answers on like number 13 is you'll see like 3 different logs. And you go, oh, okay, they want me to break it into 3 different logs. So I'll just give you that information right now so it's like the test. Excuse me. So break that into 3 different logs. 3 logs. You can break that into 3 logs. With the properties. Remember how the properties work? All right, so the properties, they're all going to be log B, log B, log B. Remember that? The base doesn't change.
Well, that one should be.
That's log B, log B, log B everywhere. No changing on that.
This one, if you don't parenthesize, then it might.
Good so far?
Log of 1.
Now what do we do with the other stuff?
625. So
You got to put the x, y to the 7th, z to the 3rd. How do we know what's like added and what's subtracted? Stuff in the top is plus, stuff in the bottom is minus. Remember that? Just like minus powers go to the bottom, minus logs are from the bottom. It's the same thing, really. And last step, remember what we do with those powers? Down to the front, down to the front. So really the 7 will end up right here. And this 3 will end up right there. And there we go. That's what they want.
I wanted to point out something on 12.
12.
You can put parentheses around 1 over 625.
Oh, yeah, thank you. You need parentheses around that.
Well, some calculators just set it up and you put it in, but
Some do.
others not.
Yeah, good, thank you. We good on 13? Remember making it into 3 logs? Oh, all right. Try Try 14. Again, same thing. They want you to break it into 3 logs again. So make that into 3 different logs.
Power inside here.
So 5 in the hook. What does that do? Do you remember? It divides every, it's right, every
So the
power by 5.
denominator.
Remember that? So whenever you have a 5 in the hook, he goes there. What am I doing?
4/5.
I'm having a bad day, aren't I? Was that 3 mistakes at least? Yeah, thank you. Yeah, so it goes underneath all 3, right? The number in the hook divides all the powers. Remember that? They're testing if you remember that rule. A lot to remember on this exam. Will not come to the casual. Don't be the casual. Not if you want to pass and get on with your life and get a bachelor's degree and get a good job you enjoy. Don't be casual. Don't be casual. That would be stupid for yourself, wouldn't it? That would be harming yourself. Consider your future. Be wise. Study hard. This exam will not go well for the casual, but it'll go well for those who put their time in. You can definitely ace this thing. I told you I've had students that have had all kinds of, they were way slower than any of you for sure at math, and they've done great. I've had students do great in this class, but it takes time. Put your time in. So divides all the, and now we got to break it into 3 logs. So how's that going to work? So you've got to take the first one, and then these guys are both in the denominator, aren't they? So they're both going to be minus log base b of y to the 5/5 minus log base b of z to the 3/5. Oh, and the 5/5, that's just 1, isn't it? I'll just make that 1. We good to there? Both the y and the z are denominator, aren't they? They're in the bottom, so they're both going to end up subtracted. A lot of people said, no, they're times, so that should be adding. Yeah, but they're times in the denominator, which really means they're divided. If you're in the denominator, you're really divided, which means it's subtracted. They will test you on that on Wednesday. The publishers test answers, they always put one with the plus, one with the minus. They want to see if you know that. So those are both minus. Now, last thing, the powers drop down to the front, huh? No, we're done. Is that good on that one? So you can get that? So just go over this thing later and practice these. Do the blank paper test. Try these on a blank paper. All right, let's try 15. Can you do 15? Now they want us to take all these and make it 1 log, single log. So again, it'll be easier on the test because you'll see all the answers are just 1 log. And you go, oh yeah, okay, I got to make them into 1 log. So see if you can take those 3 logs on number 15 and scrunch them into 1 log. Make that into 1 log. Give you a second. All right, let's take this 2 and distribute it. Bonk on a bonk. So we'll get, what will we get? So these are all log C. Log C 9x plus 2 log cx minus 2 log cy. Okay, now what do those numbers in the front do? Power, just the opposite of how these powers drop down. These powers are going to go up. We're running everything backwards now, huh? So then we can put this all into 1 log. Log base c, and then that's going to be 9x from here times x squared from there over y squared, because the minus means divide, right? Remember those properties? So the y squared goes down below. Last thing, we'll just combine those. 9x times x squared, 9x cubed over y squared. There it is. Yeah, it looks more like a 4, but it's a y. Good. 16, just hit the buttons on your calculator. Log 40 over log 8. I don't know what it is. Whatever your calculator tells you, get some kind of decimal. Remember, top goes top, bottom goes bottom. I'm going to move on. Graph. How do we do all of our graphs on this test? Graphs will be your favorite ones because it might be the easiest. How do we do all the graphs we're taking on the test? We make a table. Make a little table, right? XY table. And what do we plug in? Easiest numbers in the whole world. 0 and 1. And what letter's on the right side? X. That's the normal, right? So that's what you plug in for. Whatever letter's on the right side. X. That's what we normally find. Put in 0, put in 1. Use your calculator. So this one will be y equals e to the minus 0.6 times 0. That's e to the 0. That's 1. Anything 0 power is 1. Plug in the next one. 0.6 times 1. E to the minus 0.6. I have no idea. Some number on the calculator. I'm getting 0.54, whatever. I'll just call it 0.5. So the graph then is over 0 up 1. Over 0 up 1. And over 1 up a half right there. Whoops, over 1 up a half. So which one of those graphs is going down to the right from over 0 up 1? Yeah, it looks well, both C and D look. Oh no, it's D, huh? It's D. Right, yeah, these tick marks are 2, so this is 2. So it's hitting up at 1. We good with that? Can I move on? D? See how it's graph D? All you need is enough to figure out just one little piece. 18, can you do 18? Same kind of thing. Make 18's a graph, so just make an XY table. There'll be like 3 graphs. We've had 3, it's our third one, huh? XY table. Put in 0, put in 1. Hit the buttons on the calculator. Pieces of cake. Right? Can't do 1 either. Something interesting happens. So try that out in your calculator. Find out for yourself that 0 and 1 give errors. And when you get 0 and 1 not working, you just keep going up the line. Try 2, try 3. They're both going to be errors as well. When you get to 4, you finally get a number. Experience it for yourself. Put those in. There's nothing like experiencing math yourself. Me up here talking won't do you nearly as much good. Believe where the time went. All right, so we make our XY table, put in 0, put in 1. If you do natural log of 0 minus 3, it'll be no, 2, 3, no. Those will all be errors. When you get to 4, finally, you'll get natural log of 1, which is 0. So all we've got is the dot over 4 up 0, but that's all we need. There she is. D. I only needed 1 dot. Over 4 up 0. See that? See how that worked? So we got to number 18.